In the last two videos, we learned the method of addition and subtraction of any two given complex numbers. In this video, we shall learn the multiplication of two complex numbers. Let z1 equal to a plus bi and z2 equal to c plus di be any two complex numbers. And then the product z1, z2 is defined as follows. It means the multiplication of A with C and subtracting it with multiplication of B and D, which will be our real part, and multiplying A with D and adding it to multiplication of B with C, which will be our imaginary part. To understand it better, let us consider an example. Let z1 equal to 3 plus I5 and z2 equal to 2 plus I6. Then z1, z2 will be equal to multiplication of 3 and 2 minus multiplication of 5 and 6. Then plus I multiplication of 3 and 6 minus plus multiplication of 5 and 2. Now this can be easily solved and it will be equal to minus 24 plus 28i. Let us consider few more examples. z1 equal to 4 minus 3i and z2 equal to 2 plus i5. Now z1, z2 will be equal to 4 times 2 minus 3 times 5 plus I 4 times 5 plus minus 3 times 2, which will be equal to 4 times 2 plus 3 times 5 plus I 4 times 5 minus 3 times 2, which can be easily solved and which will be result as 23 plus 14i. Let us consider one more example. z1 equal to minus 2 plus I3 and z2 equal to 1 minus I2. Now z1, z2 will be equal to minus 2 times 1 minus 3 times minus 2 plus I minus 2 times minus 2 plus 3 times 1, which can be easily solved. We have learned already in lower classes how to solve such an easy expression, and final result will be 4 minus I. Let us now have a quick glance over the properties of multiplication of complex numbers. The first property we have is closure law. The same property, the similar property we learned in addition of complex numbers also, as in the addition of complex numbers, the sum of two complex numbers was complex number. Again, the same is here also. The multiplication of two complex numbers results in a complex number only. The second property we have is commutative law, which states that for any two complex numbers z1, z2, the following condition z1 z2 equal to z2 z1, which means the order in which the two complex numbers multiplied doesn't affect the final result. It is as if multiplying 2 times 3 or 3 times 2, both results in 6. So it's proved that the order of multiplication doesn't affect the result. The third property is associative law. For any three complex numbers z1, z2 and z3, the following statement is true. It is as if multiplying 2 times 3 times 4 and 2 times 3 times 4. The position of brackets are different in both the cases. So both the left hand side and right hand side gives us 24, which means the position of bracket does not affect the final result, which is not true with the case of division, which will be looking in the further videos. Now, the fourth property we have is multiplicative identity, which states that there exists a complex number 1 plus I0 denoted as 1, such that for every complex number z, z times 1 equal to z, which means we have to multiply such a number to our given complex number so that we get the same complex number again. So it is obvious that when we multiply 1 to any number, we get the same number again. For example, if we multiply 2 and 1, we get 2 again. The same is the case with complex numbers also. We need to get the same complex number again, so we multiply 1 plus I0 with a given complex number and get the same complex number again. The fifth property we have is multiplicative inverse, which states that for every non-zero complex number, z equal to a plus ib, here a should not be equal to 0 and b should not be equal to 0, we have the complex number a upon a square plus b square plus I b upon a square plus b square, which will be denoted by 1 upon z or z inverse, such that z times 1 upon z will be equal to 1. So here in the multiplicative inverse, the purpose is to get such a number on which multiplication to other given number, the result should be 1. For example, we have number 2 and I am asked to multiply such a number to 2 such so that I can have 1 as a result. So it is obvious that when I multiply 1 by 2 to 2, I will get 1. So same is here. I have to multiply a upon a square plus b square plus I b upon a square plus b square to the given number z, which is a plus ib. Then the final result will be 1. Here you have to remember that a and b should not be equal to 0, because if it is so, then this will become a case of multiplication, so division by 0, which is not allowed in mathematics. The sixth property we have is distributive law, which states that for any three complex numbers z1, z2 and z3, the following condition is true, which is z1 plus z2 times z3. Then we can open the brackets and write it as z1 times z3 plus z2 times z3. The similar thing we have learned in lower classes also with simple algebra, when suppose we have provided with the 2 plus 3 times 2 and we open the brackets, write it as 2 times 2 plus 3 times 2 and the final result is 10. It is very simple that we have already learned in lower classes. The similar is with complex numbers also. This was all about multiplication of two complex numbers, and in next video we will be learning the division of two complex numbers. Thank you very much.